Alright, let's go over Chapter 9 test. First problem here, reaction times, and I've typed those into my list 1 so that I can go stat, calculate the one variable statistics on list 1, and that'll give me some information here. But first let's make the stem and leaf problem deal. So I will do 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 0.81, 0.79, 0.95, 0.52, 0.69, 0.66, 0.59, 0.73, 0.75, 0.82, 0.88, 0.97, 0.52, 0.85, 0.63. And now that's my stem and leaf plot. Now we need to make a 4-class relative frequency diagram. Well, this has a natural 5, but they asked for 4. So I'm going to have to figure out how to divide this up. Well, my max was 0.97. My min was 0.52, and if I subtract those, I get a range of 0.45. And if I have to divide that into 4 categories, divided by 4, I get 0.1125. Well, if I do exactly that, that's an ugly number. I need to use something a little bit bigger, but not too much bigger, because that would make too few classes. So my tendency might be to go, say, 0.12, that's a little bit bigger, or 0.125, that happens to be 1/8. So after several times it repeat. But let's just go with a 0.12. So I would get then, and where do I want to start? Well, let's just start at 0.5. So I'm going to put a scale on here. 0.5, add 0.12, that'd be well, I'll make this 0.6, 0.7, 0.8, 0.9. I might get my 0.57 off. Let's see. That'll work. I'll make it work. 0.12, so that'd be from 0.5 to 0.62 will be my first bar. 0.5 to 0.62. Then my next class would be 0.62 up to but not including 0.74. My next class would be 0.74 up to but not including 0.86, and the next one would be 0.86 up to but not including 0.98. There's my 4 classes, and that will cover all of them. So 0.62, then up to 0.74, then up to 0.86, 5, 6, and 9, 5, 6, 7, 8. We'll take it out here just a little bit beyond. And then I got to do relative, so I have to do percentages. So first of all, let's count how many are between 0.5 and 0.62. 0.52, 0.59, 0.52, and 63 is not. So there'd be 3 in this first group. 3 in this first group. And 3 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 3 divided by 15. The first class should be 0.2. 0.2, so I'll make this 0.1, 0.2, and 3 would be 0.2 in this class. And again, the width of the bar and where you start is up to you. You could have used 1.5 and started at 5 or a 0.5 or 0.45. Used a little bit wider one, but I just chose this one because it's close to what the range divided by 4 is. And the next section I have to go from 0.62, which would be all the 0.6s, up to 0.74, which would get that one. So there'd be 4 in that class, so I'm going to do 4 divided by 15, and that comes out to be 0.27. 0.27 is about that high. No, that's 0.3. So 0.27 is about that high. Okay. And then the next class is 0.74, which would pick up those two, up to 0.86, which would get 3 out of here. That one, and those two, and those two. So that's 5 out of 15. Which would be 0.3333333 and a third. So that's about there. Up to 0.86. And then the last category to 9.8, which should have 1, 2, 3, which is the same number that the first category had, so it would be 0.2 again. And there would be my histogram. Okay. Again, answers can vary on this because when you make up new classes that are not kind of real natural ones, then you have to improvise. Okay, the Tukey 5 number summary, I could list these out in order, 15, so there would be a middle one. But I'm just going to use the calculator and have it tell me what the middle one was. And that one was 0.75, so it wants all of them, so I'll write them here. The minimum, which is Q0, is 0.52. The lower quartile, or Q1, is 0.63. The median, or quartile 2, is 0.75. And the upper quartile, or Q3, is 0.85. And the max, or Q4, is 0.97. And those are the Tukey 5 number summary. And determine if there are any outliers. So then I would have to do that. Oops, that was C. So now I'm doing D here. So I'd find the inner quartile range, which is the upper minus lower, Q3 minus Q1, which is 0.85 minus 0.63, which is 0.22. That's the inner quartile range. Then I need to find the step, which is the inner quartile range times 1.5, so that's going to be 0.22 times 1.5, which is 0.33. That's a step. And then I take the step and add it to Q3. Q3 plus a step. And that would be 0.85 plus 0.33, which is 1.15, 18. 0.18. And take Q1 and subtract a step, which is 0.33. So Q1 is 0.63 minus 0.33, which is 0.30. So the lower fence and the upper fence, these are the fences. And is there any data point lower than the lower fence? Nope. Or above the upper fence? Nope. No outliers. Beyond the fences. Okay, so draw a box plot, E. So I'll start here with a 0.5, 0.6, 0.7, 0.8, 0.9. My inner quartile, 0.63, would be from about there to 0.75, which is there, and then to 0.85, which is there. And there's my inner quartile range, and then my max is at 0.9567. And I draw the whisker to there, and I draw a whisker to the min, which is 0.52, which is about there. If I were to show the fences, this would be 0.1, 1.0, 1.05. That would be 1.1, 1.18 would be somewhere out here as a fence. And 0.3 is off my paper, be a fence. So that's the box plot. F. Use the range to estimate the standard deviation. Well, we calculated the range up here to be 0.45. With 15, we used the formula, the square root of 15. So 0.45 divided by the square root of 15 is 0.116. G. Calculate the sample mean. Now I did that. Add them up and divide by 15 and get point. I did it on the calculator here, and there's the sample mean. And then calculate the sample standard deviation. So I could do that by taking each number minus the mean, 0.116, square that, and then divide by n minus 1. After I add them all up, divide by n minus 1, and then take this, take the square root and then divide by n minus, or divide by n minus 1 and then take the square root. I get that, but the sample mean here is 0.142. I could also take each number, square it, times the probability times 1/15, and add all those up, and then subtract the mean, and then divide it by n minus 1. Yeah, there's several formulas there in the book on that. So, but the calculator is easiest. Okay, that's page 1.